Welcome back. Week 12 Python for everybody at a new place. I'm still getting used to it and I'm probably gonna swap around, but here we are. It took a long time for me to finally get to this chair and really start. And yeah, what happened this week? So this week I had a very nice, on Thursday I had a session when I read about beautiful soup, which is what is beautiful soup? I'm really out of the rhythm or everything, as you may I know already based on the previous streams. But also I had a very nice idea, let's say, to really not be discouraged and not be so hard on myself, because the amount of information you're gonna learn is really incredible. It's like you if you keep worry about like, oh, if I skip a day, or if I'm like, if you feel like you cannot allow yourself some downtime because you're gonna forget everything you learned before. Frankly, it's like there's no way you can actually remember everything we went through so far. But what's important that we go through step by step and we internalize. So next time we're gonna have a, like, we had this issue with the excuse me, when I used the string punctuation. That was a really good example from last times, that I don't understand fully, but I have a use case. And this is how I guess we're gonna progress. It's just yeah, when I'm out of it, I really feel it's getting out of my reach. But this is just a temporary state of mind. If you continue and really get invested again, then you feel back on track again. That's the thing. So no, don't. And also, yeah, the other thing is that I feel like I have to start from the, like, it feels like I have to start from the beginning because I had such a good flow. But it's, no, we started in December and we building on top of this already. I'm not a good motivational speaker, but I try. So let me to, yeah, regarding my medication, I'm going back to Ritalin because, yeah, that week was terrible. And also, yes, this is very important that when it worked, it really to use it at the same time. So now it's gonna be 1 p.m. Not ideal to take it now, and I'm not gonna have a second dose today, so I'm gonna have one. Uh, and yeah, what I want to achieve with this stream, I think really I checked briefly the first exercise. I have a bunch of questions. I don't understand fully. I don't think I understand the task at hand. So what would be nice is to, I think, just read through again. I know we did it last time, but let's read through really the networking programs, because I obviously it's gonna build on top of this, and let's see where we go. I mean, yeah. So let's see. Let's read through the networking programs again, and let's do two or three exercises. If you do anything more, I will tap you. But yeah, let's do three exercises. Let's understand three exercises today. That would be huge. And we have time. You cannot say you don't have time, because yeah, until 4 we have 3 hours. Easily I can do this. All right, let me just find my little Tritico, not Tritico, Ritalin, Jesus. Yeah, this is the new place. It's a slap of reality in your face, but I mean, at least it happened. We are done. We are here. So I mean, ideally, really, if we continue our stream, if we continue this, then you know, moon is the limit. I probably have to let the cat inside at some point. Okay, I'm here, I'm ready, let's go, let's do this. Yeah, I checked my previous streams and for some reason it was on 720p for the last couple ones. So hopefully now I changed it to proper resolution so you can actually read what I'm reading. But this guy really wants to come inside, I think. Come friends, let's go. Yes, you. Come little friend, let's go. Okay, everything is good. So yeah, I'm just gonna go through networking programs again because the repetition is the key to learning. And also, I think, yeah, I really don't understand this. So I had some kind of like with regular expressions, I have the picture. I mean, I don't know how to use them like fully, but I get the picture. But here, I think there's still a bunch of details which I don't understand. So while many of the examples in this book have focused on reading files and looking for data in those files, there are many different sources of information when one considers the internet. In this chapter, we will pretend to be a web browser and retrieve web pages using the hypertext transfer protocol. Then we will read through the web page data and parse it. The network protocol The network protocol that powers the web is actually quite simple, and there is a built-in support in Python called socket, which makes it very easy to make network connections and retrieve data over those sockets in a Python program. A socket is much like a file, except that a single socket provides a two-way connection between two programs. You can both read from and write to the same socket. If you write something to a socket, it is sent to the application at the other end of the socket. If you read from the socket, you are given the data which the other application has sent. But if you try to read a socket when the program on the other end of the socket has sent any data, You just sit and wait. If the programs on both ends of the socket simply wait for some data without sending anything, they will wait for a very long time. So an important part of programs that communicate over the internet is to have some sort of protocol. A protocol is a set of precise rules that determine who is to go first, what they are to do, and then what the responses are to that message and who sends next, and so on. In a sense, the two applications at either end of the socket are doing a dance and making sure not to step on each other's toes. There are many documents that describe these network protocols. The hypertext transfer protocol is described in the following document. Bam. Yeah, this is a big one. This is a long and complex 176-page document with a lot of details. If you find it interesting, feel free to read it all. But if you take a look around page 36 or RFC 2616, you will find the syntax for the GET request. To request a document from a web server, we make a connection to the pr4e.org server on port 80 and then send a line of the form. So I wanted to check this actually. Get. An example request line would be get to allow for transition to absolute URIs in all requests in future versions of HTTP. All HTTP/1.1 servers must accept the absolute URI in them in URI form in request, even though HTTP 1.1 clients will only generate them in request to proxies. Authority form is only used. Yeah, I mean, this is so, yeah, I'm so out of it. I have no idea what's going on. Like this network part chapter is like, I have no idea what's going on. To request a document from a web server, we make a connection. Where the second parameter is the web page we are requesting, and then we also send a blank line. This is the blank line. Aha, okay. So this is first parameter, second parameter. The web server will respond with some header information. About the document, and the blank line followed by the document. The web server will respond with some header information about the document and a blank line followed by the document content. So what happens if I just use this line? Yeah, it's really not a good idea to have the window straight into your face. It's absolutely not a good idea. I will have to move everything from here to the right. Push the bed a little closer to the wall, or yeah, and it may work, possibly. And this is gonna be my workstation. Yeah, maybe I'm gonna do this. I'm just gonna pull it down for a little bit. Much better. Yeah, I don't think this is working like this. So, never mind. Let's get back to it. And then, yeah, see, we make a connection and then send, okay? So, there is something before this. The world's simplest web browser. Perhaps the easiest way to show how the HTTP protocol works is to write a very simple Python program that makes a connection to the web server and follows the rules of the HTTP protocol to request. Isn't it funny that we call it HTTP protocol, whereas like it's already hypertext transfer protocol, so protocol to request a document and display what the server sends back. So let's really sit down, already sitting, but let's open this and really check line by line. What is actually going on here? So if we import the module, all clear. Then we create a mysock variable where what is happening here? Let's just ask. So this is something we can actually ask ChatGPT. What is this? This line of code creates a new socket object named mysock using Python's socket module. Let's break down the code. Socket. This is the Python module that provides access to the BSD socket interface. It allows communication between the processes over a network. BSD socket interface. Socket.socket. This is a constructor method within the socket module used to create a new socket object. This specifies the address, family, and the socket type for the socket. We specify the address family for the IPv4 addresses. We specify the socket type as a stream socket, which provides a reliable two-way communication between two endpoints in a connection-oriented manner using TCP protocol. So, mysock is a TCP socket object that can be used for network communications over IPv4 addresses. So, yes. First, the program makes a connection to port 80 on the server pr4e.com. Since our program is playing the role of the web browser, the HTTP protocol says we must send the get command followed by a blank line. R on or backslash R backslash N signifies an end of the line. So double times the same signifies nothing between two end of the line sequences. That is the equivalent of a blank line. Once we send that blank line, we write a loop that receives data in 512 character chunks from the socket and prints the data out until there is no more data to read. The rest returns an empty string. The program produces the following outputs. Valaki itt szétdorombolja magát. Somebody's purring a lot. It's not working. Why are you not working, huh? Should I restart? That's fucking weird. Okay, that's not so much fun. That's actually very, very far from fun. Okay, at least this one is working. Yeah, but this is quite shitty. Anyway, let's return. The output starts with headers, which the web server sends to describe the document. For example, the content type header indicates that the document is a plain text document, text/plain. After the server sends us the headers, it adds a blank line to indicate the end of the headers and then sends the actual data of the file romeo.txt. This example shows how to make a low-level network connection with sockets. Sockets can be used to communicate with a web server or with a mail server or many other kinds of servers. All that is needed is to find the document which describes the protocol and write the code to send and receive the data according to the protocol. However, since the protocol that we use most commonly is the HTTP web protocol, Python has a special library specifically designed to support the HTTP protocol for the retrieval of documents and data over the web. One of the requirements for using HTTP protocol is the need to send and receive data as bytes object instead of strings. In the preceding example, encode and decode methods convert strings into byte object and back again. So this is something we covered already. So B, you can use the encode, but you can also just put a little b here, and then it's gonna be byte. So this is gonna be a byte. And then at the end we're gonna decode. But how actually? Okay, so let's see the So okay, maybe I don't really know, but okay, basically we are feeding some stuff into mysock. Then we're gonna use a method to connect. Then we create a new variable which will have a string, but it's gonna be a byte. So we're gonna feed some bytes into this string, and then we use this send method to our mysock with the information. So basically whatever bytes were here is gonna go here, right? And then in the loop, the data, new data variable will become the mysock, where it's gonna receive this 512 per whatever. And if the length of the data is smaller than 1, then you must break, which makes sense, perfect sense. And until then, before it reaches that point, I need you to print me the data. We use a method again with an empty parameter, because yeah, data.decode. So its data has my bytes. We're gonna decode it, and then we're gonna end. Yeah, I think that's the reason why is it so freaky shit. Because many things we are going over so much detail here, which we don't necessarily understand fully. But yeah, this is hard to read. That's my problem. This is hard to read. Let's try it. Let's try again the whole thing in ChatGPT. This code is a simple Python program that acts as a very basic web browser. It retrieves the text file from a web server using HTTP protocol. Here's a breakdown of what the code does. This imports the Python socket module, which provides access to the BSD socket interference. What is the BSD socket interference? Berkeley applications. BSD sockets application programming interface is a set of standard function calls that can be used in any application. Berkeley, isn't it? That's a music school. Whatever. So this line creates a new socket object named mysock using the socket.socket constructor. It specifies that the socket will use IPv4 addresses and will be a stream socket which is a connection-oriented reliable socket type used for TCP communication. It's so much. This is too much. This is just, yeah, this line creates a new socket object named mysock using the socket.socket constructor. It specifies that the socket will use IPv4. So this thing is a constructor. And then the first argument that it has to be, yeah, so the AF inet will give us specifies that it will use IPv4 addresses and will be a stream socket, which is connection oriented reliable socket type used for TCP communication. This line connects the socket mysock to the specified server on port 80, which is default port for HTTP. This line creates an HTTP GET request to retrieve the file from the server. The request includes the method GET, the URL of the resource, and the HTTP version. The end requires the request signifies the end of the request. This line sends the HTTP GET request to the server using the socket mysock. The code then enters a loop to receive data from the server in chunks of up to 512 bytes. In the above example, we retrieved a plain text file which had new lines in the file, and we simply copied the data to the screen as the program ran. We can use a similar program to retrieve an image across using HTTP. Instead of copying the data to the screen as the program runs, we accumulate the data in a string, trim of the headers, and then save the image data to a file as follows. Import socket, import time. You can see that for this URL, the content type header indicates that body of the document is an image. Once the program completes, you can view the image data by opening the file stuff.jpg in an image viewer. As the program runs, you can see that we don't get 5120 characters each time as we call the retzv method. We get as many characters as have been transferred across the network to us by the web server at the moment we call retzv. In this example, we either get as few as 3,200 characters each time we request up to 5,120 characters of data. Your results may be different depending on your network speed. Also note that on the last call we get 3,167 bytes, which is the end of the stream, and in the next call we get a zero-length string that tells us that the server has called close on its end of the socket and there is no more data forthcoming. We can now slow down our successive redshift calls by uncommenting the call to time that sleep. This way, we will wait a quarter of a second after each call so that the server can get ahead of us and send more data to us before the redshift call again. With the delay in place, the program executes as follows. Okay, there is a buffer between the server making send requests and our application making redshift requests. When we run the program with the delay in place, at some point the server might fill up the buffer in the socket and be forced to pause until our program starts to empty the buffer. The pausing of either the sending application or the receiving application is called flow control. Flow control. We can manually send and receive data over the HTTP using the socket library while, there is a much simpler way to perform this common task in Python using the URL-lib library. Using URL-lib, you can treat a web page much like a file. You can simply indicate which web page you would like to retrieve, and the URL-lib handles all of the HTTP protocol and header details. The equivalent code to read the romo.txt file from the web using URL-lib is as follows. Import urllib.request fhand for line in fhand, print line.decode.strip. Once the web page has been opened with urllib request.urlopen, we can treat it like a file and read it through using a for loop. When the program runs, we only see the output of the contents of the file. The headers are still sent, but the URL-lib code consumes the headers and only returns the data to us. As an example, we can write a program to retrieve the data for romeo.txt and compute the frequency of each word in the file as follows. Talking away, I don't know what. Import urllib.request, urllib.parse, urllib.error, fhand urllib request.urlopen. Once again, we have opened the web page. We can read it like a local files. Reading binary files using URL-lib. Sometimes you want to retrieve a non-text or binary file such as an image or video file. The data in these files is generally not useful to print out, but you can easily make a copy of a URL to a local file on your hard disk using URL-lib. The pattern is to open the URL and use read to download the entire contents of the document into a string variable, then write that information to a local file as follows. Wow. Do do do. The pattern is to open the URL and use read to download the entire contents of the document into a string variable, then write that information to a local file as follows. So but we don't use hard disk anymore, old timer. No, actually I do have a hard disk. So import URL lib.request, URL lib. Yeah, what are these things? The fuck? URL lib.request, URL data open. This program reads all of the data in at once across the network and stores it in the variable EMG in the main memory of your computer, then opens the file and writes the data out to your disk. The web argument for open opens a binary file for writing only. This program will work if the size of the file is less than the size of the memory of your computer. However, if this is a large audio or video file, this program may crash or at least run extremely slowly when your computer runs out of memory. In order to avoid running out of memory, we retrieve the data in blocks or buffers and then write each block to your disk before retrieving the next block. This way, the program can read any size file without using all of the memory you have in your computer. So this is, yeah, this basically the same. Did we make a note of this? Yes, we did. If lambda info, yeah, break. In this example, we read only 100,000 characters at a time, and then we write those characters to the cover3.jpg file before retrieving the next 100,000 characters of the data from the web. This program runs as follows. Okay. Parsing HTML and scraping the web. One of the common uses of the URL lib capability in Python is to scrape the web. Web scraping is when we write a program that pretends to be a web browser and retrieves pages, then examines the data in those pages looking for patterns. As an example, a search engine such as Google will look at the source of one web page and extract the links to other pages and retrieve those pages, extracting links and so on. Using this technique, Google spiders its way through nearly all of the pages on the web. Google also uses the frequency of links from pages it finds to a particular page as one measure of how important a page is and how high the page should appear in its search results. Let's put a spider. Let's put the spider picture here, just for good measure. Spider Murphy. I don't see it. Where is the what was the name of that bot anyway? You can buy one for only 8,000 crowns. Parsing HTML using regular expressions. One simple way to parse HTML is to use regular expressions to repeatedly search for and extract substrings that match a particular pattern. Here's a simple web page. From getting ideas, Jesus Christ, it's crazy. It's really crazy how they're coming up. It's starting to switch your whole. It feels like your brain cells is just starting to waking up. But I have such a big fear of like, oh no, this is only temporary, and I'm gonna go back to this. I think that's the reason. That's the main key. That you know it's real, right? Like you know it's working, and you know it's possible based on the previous month and everything and weeks. There's definitely is a possibility to stick by a routine and being, learning new things. This is like 100% possible. But when it's over, right? When it's done, then you fall back to the your ADHD. And if you have control over this, even it's like, yeah, right, I'm not productive anymore. I'm not in my learning phase. But if you still have control and over your sleeping, what do you do before sleeping or anything, or what we just did this morning, that was like awful. But if we have control over this, then it would be so fucking awesome. It would be so amazing. Let me write down my ideas. So I remember like last week. This is probably not gonna make too much sense, but just some raw ideas. But yeah, somebody can steal your ideas, man. Why would you even stream that? Fuck you. Anyway, so I was thinking about this. It's for me only, so I don't care. But so as I was learning about regular expression as modules, to have tabletop tabletop game with regarding Python with actual characters, with all of the tools like modules, functions, methods, everything. Like everything we use and name that has a name would be like formed into table that came regarding Python with all of the tools, modules, functions, methods forming into a character figure, which really represents what are they doing. So for example, okay, so string. Like even len, see, len is a function, so len would be really something which is like width, like some character which would like could go even like that's the len. I don't know. Okay, well, I mean, and cards, I guess, cards as well. Okay, and the other idea, this just briefly, is to, yeah, program but this is extremely hard. All right, let's go back. So we can construct a well-formed regular expression to match and extract the link values from the above text as follows. href equals http blah 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 blah. A regular expression looks for strings that starts with href blah blah blah, or href, yeah, followed by one or more characters, followed by another double quote. The question mark behind the s question mark indicates to search for string followed by 0 or 1s. So this is something which we understood finally. Fuck. Because like I didn't understand at the beginning, like what was this greedy, like non-greedy behavior. But it basically means that yeah, if you put the question mark, it will be the shortest possible string, and not, it will not look for the largest one. But what is the limit though? Like that's the question. We add parentheses to our regular expression to indicate which part of our match string we would like to extract and produce the following program. The SSL library allows this program to access websites that strictly enforce HTTPS. The read method returns HTML source code as a bytes object instead of returning the HTTP response object. The find our regular expression method will give us a list of all of the strings that match our regular expression, returning only the link text between the double quotes. When we run the program and input a URL, we get the following output. Regular expressions work very nicely when your HTML is well formatted and predictable, but since there are a lot of broken HTML pages out there, a solution only using regular expressions might either miss some valid links or end up with bad data. This can be solved by using a robust HTML parsing library. Parsing HTML using Beautiful Soup. Even though HTML looks like XML and some pages are carefully constructed to be XML, most HTML is generally broken in ways that cause an XML parser to reject the entire page of HTML as improperly formed. There are a number of Python libraries which can help you parse HTML and extract data from the pages. Each of the libraries has its strengths and weaknesses, and you can pick one based on your needs. As an example, we will simply parse some HTML input and extract links using the Beautiful Soup library. Beautiful Soup tolerates highly flawed HTML and still lets you extract the data you need. You can download and install the Beautiful Soup code from here. So we did this on Thursday. That was, I remember I was like quite focused. We will use URL-lib to read through the page and then use Beautiful Soup to extract the href attributes from the anchor A tags. Gyönyörű leves. This program prompts for a web address, then opens the web page, reads the data, and passes the data to Beautiful Soup parser, and then retrieves all of the anchor tags and prints out the href attributes for each tag. But you know what's really like crazy about this whole chapter? Because it gives you like homework to read about the pip. That's one thing. You even need to read about like what is actually beautiful. What is this Beautiful Soup library? But what is this? And then it asks you to read about, I mean, you can even read about the socket, and you can read about the HTTP. Like, yeah, this RFC 2616. Crazy. It's absolutely insane. Yeah, but this is all about the HTTP, and it's super dry. Yeah, that would be the key. Really need like a routine where you, yeah, we should stream even after work. We go home after work and we do like, okay, we sit down and we just, but that's the thing, it's not working anymore at the time. That's why I really hope that Concerta will be coming back. Anyway, let's continue. Let's continue to our Beautiful Soup. This list is much longer because some HTML anchor tags are relative path or in-page references that do not include, which was a requirement in a regular expression. You can use Beautiful Soup to pull out various parts of each tag. HTML.parser is the HTML parser included in the standard Python free library. Information about HTML parsers is available at Okay, I'm gonna make a T. I forgot that I don't have sound yet. At least you guys can listen to it. If you have a Linux, Unix, or Macintosh computer, you probably have commands built into your operating system that retrieves both plain text and binary files using HTTP or FTP protocols. One of these commands is QRL. The command QRL is a short for this fridge is absolute trash. The command QRL is a short for copy URL, and so the two examples listed earlier to retrieve binary files with URL-lib are cleverly named QRL1 and QRL2. Okay, as they implement similar functionality to the QRL command, there is also a QRL.free sample program that does this little task a little more effectively in case you actually want to use this pattern in a program you are writing. A second command that functions very similarly is wget. Both of these commands make retrieving web page and remote files a simple task. Oh no. Okay, so here we are at the exercises, and let's do it. Change the socket program to prompt the user for the URL so it can read any web page. You can use split to break the URL into its component parts so you can extract the host name for the socket connect call. Okay, so I guess now I understand. It can read any web page. So, which means, and what are we trying to do here, right? What is socket 1 doing in the first place? This is simple, this is all clear. And let me open up my... Man, it's weird now, no? Like something is not okay with this. Anyway, yeah, because I did an update, right? And maybe it did some silly stuff. Anyway, so what is gonna be the difference? So we can enter a URL, right? But we don't know what we're gonna get, right? We don't know actually what do we need. Like we need maybe some a web page, we know, but it's that it can read any web page. But the web page should get now, we want this, that takes the, like, how do I translate this into any other website? And it says you can use split to break the URL into its components part, so you can extract the host name for the socket connect call. Yeah, also don't think that this is something like extremely. I don't understand what do you mean you can use split to break the URL into its component parts? Like, we never talked about split before. Oh wait, sorry, my bad. So we import so we need a regular expression. Okay. The equivalent code to read the romao.txt file from the web using URL lib as follows. Change socket program to prompt the user for any web page for the socket connect call. Yeah, but that's the thing. We don't know what we want to read. Like, we don't know. We have no idea what we want to get, right? Like, we have no idea. We know that we're gonna connect to a URL, right? And that's it. Okay, so get. Wait a second. Okay. Maybe I get it now. No. Because it's gonna get from here. Like, how do you know the address? No, maybe I will get the, yeah, just the URL. We should add a parameter. I don't know how. What should I do with this line? Basically, this is something I don't understand. Okay, now it's the fun part. I don't know. I guess we need to restart like completely or something like this. This is so bad. This is horrible. Something about the keyboard, right? Is there anything like F lock? Oh my god, yeah, that was it. Interesting. All right, so See, it doesn't even, yeah, text. Okay, there is content type. I hope I don't have. Yeah, this is. I'm not gonna be a network guy for sure. Hell no. Like I understand. Like so far, you know, I definitely don't want to deal with networks stuff. Just too many numbers. Here we know the URL, right? What happens if I just open this page? Okay, I get it now. I get it now. So we want to actually, like, we can even use this little, like, example page, right? But we want to give the option, like, hey, you can choose any of the pages. And that we know, because we know that here there is, okay, I get it now. I get it now. Yeah, from the, so it can read any web page. Prompt the user for the URL, so you can use split to break the URL into its component parts, so you can extract the host name. Excuse me. Fuck. So that's the thing. Okay, so we want to get in the get here, we want this to be an input. We enter the URL, right? So we need basically the second. So it can read prompt user for the URL. So it can read any web page. All right. So it means, but I still don't know what I'm gonna do with the, like how I'm gonna modify it, right? So here I'm gonna enter the whole thing, like that I want to open, the whole URL, like this. Yeah, but we don't want to, yes, okay, so we don't want to like read all of this shit into it. We just only want the host name. So how are we gonna do that? See, like here basically. As an example, we can write a program to retrieve the data for Romeo.txt and compute the frequency. Okay, no, we just want the normal one. So for line, okay. The equivalent code to read Romeo.txt from the web using URL lib is as follows. URL lib.request.url print. Okay, so what happens here? But why does it even work? Here we should have the... No? That's fucking weird that this even works without, like, these are not being function strip. Is this like a, is this reserved? Okay, we don't care about that. That's fine. What happens? Okay, so host name. If we use the split, the host name becomes. Is it the dictionary now or what the fuck? It's a list. Okay, so it becomes a list. Okay, because we see we forgot about this. But yeah, the split is gonna return a list. Returns a list. So anyway. just want to see what's inside here again. So we have a list. We will create a list. And what was the URL here? Right, data, okay, perfect. So it's gonna be 2. But see, it's like, like it's only gonna work with this specific. But anyway, let's try to make it with this specific type, and that's it. So data, okay. So the URL host name is gonna be, and host name 2. We don't even do this first. Let's do it like this. Yeah, see, so it's working, yeah. But can I do it in one? I don't think I need to do like immediately. Like, why would I create? And it's a string. That's nice. So it does extract the string. Okay. Yeah. So this is done. But we need to understand bad request. Now this is a bad request. Because, okay, so when we connect here, it's already a byte, right? We create a byte from it. No. No, this is just a string here or whatever, I don't know. But mysuck.connect to the Algae, definitely. So we just need to understand what are we gonna do with the CMD. That's gonna be the full one. I think we shouldn't do it for now like this. We should just fuck the input. Fuck the input now. We just need, because the URL is still gonna be the same. So let's fuck this for now, because like every single time entering the URL is not a smart idea. But see, that's the problem, because it's still gonna get the, I think we need to split it even more. But no, see, HTTP, this is the first address. This is the full address, right? So what happens here with the CMD? I think we can try to do the encode. What happens if we do the encode here? Yeah, I think you shot yourself in the foot with this. It's dot encode. So if I don't do this, I don't know. I don't know how you're gonna like put there the URL, unless if you just this is not right. I don't even understand how can we use this get, which is looks like just a string, and why is it now suddenly under these circumstances it does. Like, I don't know how to manipulate this get. We must send a get command followed by a blank line. Okay, right. So we're gonna, yeah, so in the CMD, basically we are already, like, we are basically sending to the web server. Yeah, okay, maybe. Yeah, I lost them. I lost myself. Uh, the clouds look really cool from here. Okay, I think that's all I need to do is create something which will basically get the Elche. Like, yeah, I need to get the whole this URL into here. So I just need to create something which will, yeah, put this together and as a first as a string, and then create it into a byte. How do you do that? How do you do that? This is not shouldn't be that problematic. This is string parsing or string. This is slicing, or I have no idea. Yeah, I need to check the manual of the string methods, basically. Or yeah, that's the thing. I need to pull up the manual and see what can help us from here. Definitely. Pull up the documentation. String methods. Split the string at the first. No, like add something to the string. I don't think it works like this, but fine. So I guess this is fine. See, that's what I'm talking about. See, it actually works. So maybe it's gonna work. Let's say so. Get plus URL plus da 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 da, and then CMD is gonna be okay. But can I now make a byte from this little guy? Or encode. Get dot encode. And what parameter or argument I can put here? Maybe I can put some argument there, right? But anyway, let's see. What's the problem? Why is this a problem now? So let's see it from here then. Let's check here as well. We can just compare and we will know. Can I use another one? You want that? Yes, of course I want another instance. So in this case, thank you. So in this case, what happens, right? Because CMD becomes, it's a byte. I don't understand what's the problem. Okay, I get it now. I get it now. Okay. I get it now because I'm sending, yeah, I'm not sending what's actually in it, but I'm sending the stupid, yeah, okay. And how did we solve this? Yeah, I remember about this because now what I'm sending is the method itself. But how can I? Yeah, I remember about this. But how did we solve this? I remember this very much. Do I have some notes about aha moments or something? Yeah, this is super nice. See, that's what I'm. This is super nice session. This is very nice session again because we actually think about it. We are going deeper and deeper. So the problem is we are sending the when you run this little guy, you can tell that this is a wait. No, okay. For a moment, I thought I'm right. I'm not right. Shit. Ah, okay. Okay, okay, okay. So yeah, the problem is that I'm gonna send with the B, right? But we don't actually need these two. Or maybe we need to add it to a variable and then add it to a, yes, maybe, right? Because we are sending it, even though it's a byte, we are already sending it with a B. Yeah. Ooh, fuck. Oh, fuck. No, I don't know. Okay, let's try. So let's see it here, for example. Let's print the B. It's the same. Yeah, it's still the same. So it's B get. Okay, what do I do? And it's exactly the same. It's exactly the same. Wait. No, it's here. Maybe the S is a problem. The HTTPS is a problem. Maybe it's a problem. Yeah, the HTTPS was a problem. So we need to understand what the fuck is HTTPS in the first place. What's the difference? I'm sorry. Excuse me. Change, it can read any web page. So now our program can read, it cannot read the HTTPS for some reason. Yeah, but now I understood. Very nice. Check using and try to add error checking using try and accept to handle the condition where the user is improperly formatted or non-existent URL. But if I would add the s, would it? I don't think it would work. Yeah, this is a big rabbit hole here. This is a very big rabbit hole because like it depends on so many factors if it's gonna work or not. Yeah. But good. What did you use? At least you used the split. We understood when to use the split. We used indexing, and we did a string parsing. Is it called string parsing? Concatenation. We did concatenation here. Yeah, this is a big rabbit hole, to be honest, because it will only work with HTTP, and you're not making it clear for me if I should count for that one or not. Thank you for opening this fucking browser. Oh god. I'm not gonna be able to read any web page. Like, that's just impossible. But in that case, I will have to find out how to open with secure. Anyway, like, we can test this with at least with this one. So do you think in this exercise, when he asks, like, prompt the user for the URL so it can read? Okay, no, I'm gonna re-record this. Do you think in this exercise they want me to, like to, oh fuck. I'm just gonna write it. See, it's beautiful, but let's try. Let's try to find like a website with poems or something. Is anybody out there? I don't think so. Do, 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 do. This is nice. Thank you so much. So this is nice. But I don't think this is not gonna work because it's not a file. We don't even know. So what kind of a format is this now when it's just like this? But this is very cool. This is like super duper cool. See, that's what I was talking about. Like it's like you just get back to it and it's super nice. We can get all of these informations. So that's cool. Yeah, we just need to find out how to create this into HTTP. Basically, we are creating a web browser here. Okay. You don't have to comment every thought of yours. Okay, wait, yes. The SSL library allows this program to access websites that strictly enforce HTTPS. So it's literally there. The read method return, the SSL library. Hmm. Can I add it here? Egészségedre. Okay, I need a break. So, I was thinking that now it's the perfect time for some chicken, but also to watch Dr. Chuck, because why not? We can like watch this whole part where he talks about the networking programs. That would be perfect.
Now, the nice thing about 0 is the next thing we're going to do is we're going to add 1 to it, so that's going to get us to 1. So collapsing that loop that we saw before, we can make it just a one-line loop. And this will become, Greedy would find a dollar sign and one character, and then it would give us $1 rather than $10. So, in summary, regular expressions are a cryptic but powerful language, and they're an acquired taste. I bet eventually you'll find them fun, even though on your first impression you might not think that they're so fun. Welcome to Networked Programs. This is Chapter 12. Now we're going to learn a little bit about how we talk to resources on the network using Python. Now, this is a really quick introduction to how the network really works. I have a whole book that I wrote. It's also translated into Spanish on how the network works, starting at the very lowest layer, packets and everything, right on up. And it's actually really easy to read. I wrote it for a high school audience. It's a short book and pretty easy to read. So if you read that book, you will understand that there is this layered architecture, the TCP architecture that sort of runs our network. At the lowest layer, that on one side here, this is your computer and this is a server computer. And if you sort of want a web page, it goes across the network, does this like 15 or 20 times, then it goes up into the server, reads the data, and then the data comes back, 15, 20 hops for the packets, and then it's shown to you as what you see. And so that's how it works, and there's these layers that we're not going to talk about in this section, but I talk about in that book. The layers of the link layer, which talk about how to get over one hop, the internet layer, which talks about how to construct, say, 15 or so hops to get packets back and forth. That's the sort of lower level bits. We're going to start at what we call the transport layer, and that's the layer where your computer sort of assumes that it can make a phone call to another computer, another process running on a program on this computer, talks to a program on this computer, and then it kind of comes back. Okay, and so we're gonna leave this alone. We're going to ignore it. We're going to assume that there's this nice reliable pipe that's going from point A to point B, and what are we going to do with the pipe? But if you're interested, take a look at the book. So we're going to start with a pipe, some kind of a connection. We have two processes. Process, and we have some kind of a connection between them. And it is a connection that we can both use to talk and to listen. In nerd terms, we call these things sockets, and that is one process running on one computer, another process running on one computer, another second computer connected through the internet somehow, and one computer speaks into that socket and it comes out, and the other computer returns something and it comes. And so this is a bidirectional protocol of data, which is a series of, in effect, data phone calls between applications. So the application might be on your side, this might be your browser, Chrome, Firefox, Internet Explorer. On the other side, this is a web server. Might be Internet IIS, Internet something something from Microsoft, or Apache, or Java Tomcat. There's another program, and you are making phone calls between these programs. Now, in general, these servers here stay up all the time, and you sort of just can make a request when you feel like it in your program. But that's what we're going to do, and this is what we call a socket. So that little connection, that phone call, that data phone call, is what we call a socket. Now, you have to decide which of the systems you're going to talk to and then which of the services on those systems, or which process. And so we have this concept called port numbers, and they're best thought of like extensions on phones. So one organization has one phone number and it says, please enter the extension of the party you'd like to talk to. Well, that's kind of what ports are. They're like, here is, I'm a server and I'm connected to the internet. Please enter the extension of the process that you would like to talk to. And so, for example, there might be processes running on various computers, And so the email is known to hang out on port 25 or extension 25. Login, insecure login lives on port 23. Insecure web lives on 80 and secure web lives on 443. And there's a couple of different protocols. Say if you have your mail stored on Gmail and you have a local mail client, say like Thunderbird or Apple Mail, that talks a protocol to pull that mail across. And those live on various ports. So these ports are those extensions. And by convention, we have standards that tell us what to roughly expect at those ports. So when you're talking to port 80, you expect to talk to a web server or an HTTP server. If you're talking on port 23, you expect to talk to a telnet server, and on and on and on and on. And so these are the extensions, the typical, commonly used default extensions for various network application processes that are serving us data. Now sometimes you'll go to a URL and you'll see in that URL there's a colon and a number. That means it's a web server that's running on a port other than the official 80 or 443 port. Now in Python we can talk to these sockets, right? We can just talk to them, and it's really easy, surprisingly easy. We have to import socket because that's a library. It comes with Python, but until you can use it, you can't use it in your program until you say it. And then you basically in the socket library you call socket function. That's what that syntax is saying. You're making a socket. Now the key to a socket, it's sort of like an unopened file handle. It's half of a file handle. It's an outward looking thing that's not yet connected. These parameters, you're just going to type them in. This says we're going to make a socket that goes across the internet, and it's a stream socket, which means that it's a series of characters that come one after another rather than a series of blocks of text. There's another kind that's harder to deal with, but we're going to do this. So this, don't worry about this line. Just know that this creates a socket but does not associate it. The very next line, we get back a socket object in this variable that I'm storing in the variable mysock. And then when you want to make a connection across the internet to the far end, you say, oh, hey, dear socket, extend yourself across the internet. Make the phone call to this host, data.pr4e.org, and on that port 80. So that's making the phone call. This is like the phone number, and this is like the phone extension. So we haven't sent any data yet. We have simply rung the phone of a process, hopefully living on port 80. If it's there, great. This might blow up. This one here won't blow up, but this line here could blow up. If there's nothing sitting on that process, it would come back and say, oh, you tried to call, you got no answer. That's a legitimate thing to happen. Maybe you don't have a network connection, or maybe that service is down on that server, or the whole server's down. But so it's kind of amazing that we're sitting here in Python, and in 3 lines we have probably 500,000 engineers have built this thing called the internet, all these protocols and all this software, and we just made use of it in 3 lines of Python. And I guess this is one of the reasons that people absolutely love Python. Absolutely love Python. So now that we have a socket, we have to add ask ourselves, what kind of data are we going to send, and then what kind of data are we going to expect to receive across that socket. So now we have a socket, we are going to talk about what we're going to do with it, right? So the socket basically functions at this level. Your application is saying, make me a socket, which is sort of this endpoint, and then the connect actually connects to an application on the far side. And there's a port involved, so that might be port 80. And this is the far host, and that could be www.py4e.org or data.py4e.org. Okay, and so the socket is solving this, and the question then is, what are we going to send and what are we going to expect to get back? And that's what we call the application protocol. So we know that these two have made a phone call. And it's no different than making the phone call and saying, you know, hello, right? And everyone knows that when the phone rings and you pick it up, you're supposed to say hello. And that's part of our protocol. So who talks first, right? So the dominant protocol that we use on in this section is the HTTP protocol. The key is hypertext transfer protocol. It's dominant. It's really easy to use. That's why I use it as an example. But realize that there are many others like mail and file transfer and remote login and all kinds of other protocols. Each is a different application protocol. They all use sort of sockets at their lower level. But then on top of that, they layer the rules of the road for retrieving hypertext web pages. And we have used these for all kinds of other things. So the protocol, like I said, is like who answers the phone first, what do they say, what happens if the person doesn't answer right, can you hear me now, those kinds of things. And it's a real simple thing, and all you really need to do is so that both sides can agree, you have to write a thing that's like the rules in the middle and say, okay, everybody, as long as we all do this, we'll be fine. It's as simple as picking on which side of the road the cars can drive on. It works fine no matter which side, but if each car randomly picked, it would be really kind of a mess. So if you look at the typical URL, and this is one of the things that the web innovators in 1980 really invented that was wonderful, and it seems second nature today, but in 1990 it was rather revolutionary in that these uniform resource locators included in themselves a protocol, the host to connect to, and the document to retrieve. So this is one of the clever ideas that the web came up with, because we used to have to pick a program like FTP or Telnet or whatever, SMTP, then we had to go to the right host, and then we had to talk to that host a certain way. So in HTTP, it's a really simple protocol invented in 1989 and 1990 by Tim Berners-Lee and Robert Caillou at CERN. And they created a protocol that we have grown to know and love and use for way more than retrieving documents, as we'll see in the upcoming chapters. So we're going to talk a little bit about what happens when you click on a page that has a link. Now, there's all kind of fancy stuff that can go on, but this is the basics. And so let's just imagine for the moment you are sitting looking at a web page, drchuck.com/page1, and inside that there is a hyperlink. It is a indication that says when you clicked on this page, go to a different page. And in that you see the name of the page that you're supposed to go to. So we click on this link, and that is a browser. This is an application. This is a process or an app that's running on your computer. This is the browser, okay? And when the browser sees the click inside your computer, then the browser makes a connection to port 80 on the web server, drchuck.com, and sends the request. This request that it sends is precisely specified by a standard, which we will see in a second. Then the web server does some magic work. Oops, let's go back. Then the web server does some magic work in here, reads some files, runs some code, does whatever, constructs an answer to our phone call, and sends it back. And it sends, in this case, back a web page in the format of HTML, the hypertext markup language, which is different than HTTP, which is the protocol that we're exchanging. HTML is the format of the document we're getting back. And in this has an anchor tag, href, and the end of anchor tag, and some highlighted text. And now your browser gets this back and then renders it according to the rules of HTML and CSS and JavaScript, etc., parses it, and then makes a pretty web page. And this web page happens to have a link back to the first page, and if you click there, it will do this over and over and over again. And that is the request response cycle. And that's governed by a series of internet standards. These are standards that were built from the 60s, 70s, 80s, and 90s and continue to this day by a group called the Internet Engineering Task Force, or IETF. The documents they produce are called RFCs, which stands for Request for Comments. The word RFC is kind of like a sort of joke, as it were. They're trying to be kind of funny in that. Funny is not the right word. It's ironic in that they're trying to say, even some of the protocols of the internet that we've used for several decades, they're always interested in improvements, and that's what the RFC stands for, and they're all named RFC-whatever. And if we were going to cruise around, we could find some various RFCs, and this is RFC 2616. It might have been revised since then, but this is like a document, and this is what they look like. Hypertext Transfer Protocol,
All right. So there were some distractions, but we are back. Um, but what was the most important part? That he has actually a book about this. So let's check.
This thing. And so we're gonna read through and look for lines in a file that have this form. And we're going to extract this number, and then we are going to, you would find a dollar sign and one character. And then summary, regular expressions are a cryptic but powerful language, and they're an acquired taste. I think that I bet eventually you'll find them fun, even though on your first impression you might not think that they're so fun. Welcome to Networked Programs. This is Chapter 12. Now we're going to learn a little bit about how we talk to resources on the network using Python. Now, this is a really quick introduction to how the network really works. I have a whole book that I wrote. It's also translated into Spanish on how the network works, starting at the very lowest.
Okay, I have to leave. It's happening. So, yeah, well, I would say very nice session. I will keep working on it. That's the thing. Like, you must know yourself and be able to control yourself. Just because I'm streaming, it doesn't. Or like, I mean, you can be interested. It's proven that you can ask questions and you can get deep into the topic when you're streaming because you feel like you're accountable or whatever. I don't know what the psychological reason behind it, but the key is that when I stop the streaming, you can continue this interest. You can continue this. You can replace your phone swapping with actually reading about stuff. And I do believe we have the power to do this. I really do. And then every time, if we're gonna do this, all of our next sessions is gonna be even more fruitful, whatever. So anyway, tomorrow badminton, but in the morning we can do it. I think so tomorrow morning. Nice breakfast, and we sit down and we continue.